Okay, first component, cell. Okay, you have battery, the symbol, remember the symbol. Here, the longer line means it is the positive terminal and the shorter line is the negative terminal. All right, so a battery has two terminals, positive terminal and negative terminal. So you can stack one cell. A cell is just a single battery. Okay, so if I draw like this, multiple cells, right, like this, so I can stack it up like this, multiple cells like this. So if one cell is 1.5 volt and this is 3 volt and this is 4.5 volt. Okay, now then we have the symbol for a load. Okay, a load can be anything. It can be anything that you want to power in the circuit. It can be light bulb, a speaker, electric heater, okay, anything. Right, then we have the switch. Now the switch is to control the circuit, all right? So whether it is open circuit or closed circuit, later we'll go into the difference between open and closed circuit. Okay, so a switch is used to disconnect or connect a circuit. And then we have resistor. What is resistor? A resistor has resistance that slows down the current flow. Okay, you can think of it like something that slows down the current flow or something that opposes the current flow. The higher the resistance, the smaller the current will be in the circuit. Okay, then the next one is fuse. What is a fuse? Fuse, and this one is made of very thin wire. Inside the fuse, right, is made of very thin wire that if very large current flow past it, that thin wire inside will heat up and then it will melt. Once the wire inside melt, then the circuit is disconnected, meaning that no current can flow anymore. Okay, if too large current flow through the fuse, then the wire will melt and no more current can flow. It will cut the circuit because when the wire melt, it disconnects the whole circuit. Okay, so that is the function of the fuse. What is it used for? It is used to prevent too large current flowing. Like in your laptop, in your any electrical appliances, you have to have a fuse, right? So if suddenly there's a spike in current, right? You need to protect your device. So you need a fuse to break the circuit, right? So we'll go more into fuse in the following chapters, okay? So just here is just a brief function of each component, okay? So that is for fuse. And the symbol, remember the symbol. So you have the rectangular box and inside there's this one line. Okay, the next one is ammeter. Ammeter and voltmeter, right? Ammeter is used to measure current, measure the current in the circuit, and voltmeter is to measure voltage in the circuit. Now, the difference between current and voltage will be discussed in the following part. We'll save it for later, okay? So here we are just looking at the component and what is the function of each component. So ammeter, voltmeter used to measure current and voltage in the circuit. And then also we have, okay, switch, closed switch and open switch is the same thing lah. It's just that one is connected, another one is disconnected. Now you see, open switch does not mean that the circuit is open. Okay, open switch means that the switch is disconnected. So if the switch is disconnected, then that means current cannot flow. Okay, it cannot flow past the switch. So that means the circuit would be closed, meaning that the bulb, if you connect any load in the circuit, the bulb, let's say like a bulb, it couldn't light up. Okay, it will not light up because the switch is open. That means it's disconnected. Okay, so here, closed switch means that the switch is connected. So is there any current flow in the circuit? Yes, okay, there's current flow in the circuit. So remember this too. If closed switch, that means current flow. Current flowing. If open switch, that means current. There's no current in the circuit because open switch means disconnected switch. Closed switch means connected switch. Okay, yeah? Okay. And the last one, variable resistor. Now, you have two types of resistors. One is a fixed one. The one on the left, this is a fixed resistor. And another one is a variable. Variable means you can adjust. You can increase the resistance or you can decrease the resistance. If you increase the resistance, then it would affect the current in the circuit. You decrease, also it will affect the current in the circuit. So that means you can adjust the current in the circuit using a variable resistors. Okay, so two types. Now, any electrical component has certain degree of resistance. Okay, any component, they have certain amount of resistance to current. Okay, so that means there is certain degree of resistance that will slow down the current flow in the circuit when you put any electrical component inside the circuit. Okay, now here, please remember all the symbols for each component and a brief description of the function of each one. Okay, now look at number 5. Here we got two types of circuits. A circuit can be open circuit or a closed circuit. Now, again, open circuit means what? Open circuit, is there any current flowing? Open circuit, this is switch. Switch is disconnected, right? Disconnected. Disconnected. Open circuit means there is no current flow. And closed circuit means there is current flow. Okay, look at the first column. It is also called incomplete circuit. Why we say incomplete? Because current cannot flow in the circuit. There's no complete path. If there's any break in the circuit, then current cannot complete the circuit. Okay, so if current cannot complete the circuit, then there's no current in the circuit. Okay, anywhere. Point A over here, point B over here, before the switch, after the switch, also there's no current. Okay, you cannot say like, okay, current flow from here and then stop here. So there's current flowing here on the left side and there's no current on the right side. No. If it's incomplete, then it's incomplete. There's no current. Okay, everywhere, no current. All right, the switch is open, hence there is a break in the circuit. There is a break in the path of the circuit. So no electricity flows in the circuit. And an open circuit can also be caused by faulty working devices or a break in the protective devices. That means if you have, for example, if you have devices in the circuit, if that device happen to be damaged, okay, there's fault in the device is damaged, that means there is a break in the circuit. So that can also cause open circuit. That can also cause the circuit to become incomplete. Okay, so let's say you have like 2 bulbs here, and if one bulb is damaged because there's this break in the internal wiring, it can cut the circuit. Okay, one bulb is damaged, it can cut the whole circuit, because if one bulb is damaged, then current cannot flow past the bulb. It cannot flow past, it cannot flow past the bulb, then it becomes a open circuit. Okay, incomplete circuit. Now, on the other hand, we have a closed circuit. So it is also called complete circuit because there is a complete path and the switch is closed, hence the circuit is complete. Electricity flows continuously in the circuit, okay, continuously. In this example, the light bulb lights up. Please take note of point number 4 and point number 5. Now we are going to go to the circuit construction. Let me share my screen here. Okay. Now, here we are going to look at the two types of circuits: open circuit, closed circuit, and also series and parallel circuit. Okay, that is on textbook page 207. Now, I'm going to first construct a simple circuit. So a simple circuit is made of, we have a power supply, and then we have a conducting wire, a copper wire, and here a simple circuit is made of a power supply, a load, a resistor, a switch. That's it. The rest is like ammeter, voltmeter that you want to measure the current. Okay, so let me form a simple circuit, a series circuit here. So I'm going to draw like this. Okay, I attach my resistor over here. And then my switch. And here's my bulb. Okay. Now, is there any current flowing in this circuit? Look carefully. Look at the switch. Switch is not, is it an open switch or is it a closed switch? Open circuit or closed circuit? It's open circuit, right? Because the switch here is not connected, right? So is there current flowing in the circuit? No, there's no current. Now, if I close the circuit, I close the circuit means I close the switch. Okay, I close the switch means that there will be current flow. Okay, because I close the switch, I provide a complete path for the current to flow. So you can see the bulb lights up. Okay, now again, closed circuit, open circuit. Open circuit, no light. Closed circuit, lights up. Now I want you to observe the current flow. You see, what is the direction of the current? Huh? Current, from the last lesson, if you remember, current flows from positive to negative. So let's say I draw my circuit like this. We have negative terminal and we have positive terminal. Okay. Remember, when you connect the wire, there is an electric field between the positive and negative. So if I put a positive charge starting from here, where do you think the positive charge will move? Positive and positive, they repel or attract? Same charge, they repel. Okay, if different charge, they attract. So positive and positive, they repel each other. Repel means move away. Okay, move away. So they move away from each other, meaning that if you put a positive charge at the positive terminal, then it will move over here to the right, right? Since there's only two ways it can move, left or right. So if it moves right, then it continues to move here, reach the other end, the negative terminal. Okay, it will be repelled by this positive and be attracted to the negative. Now remember, current direction, we describe current direction the same as the direction of a moving positive charge. Again, the positive charge moves clockwise. So we define that the current flow follows the direction of a positive charge. So if the positive charge takes a clockwise, then the current flow is also clockwise. Okay, movement, here I write here, movement of positive charge, same as current flow. Please remember this. Movement of positive charge is the same as current flow. That means current flow from positive terminal to negative terminal. Can current flow from negative to positive? No. Okay, positive to negative always. So if you want to label where is the current flowing, Then you put arrow from positive coming out here. Oops, you don't see orange coming out here, and then to negative terminal. That is the flow of the current direction. Okay, so always come up from positive. Now look at the circuit here that I have constructed. Here I'm going to show the current flow. You can see the arrow moving. Where is it moving? To the in clockwise direction, right? Clockwise direction. Now this arrow, the tiny arrows, shows that the flow of current. So it's in the clockwise directions. So if I change this circuit to the symbol here, where is your negative terminal? This is your negative terminal on the left. And here's your positive terminal on the right. Okay, so current flow from positive to negative. But inside the battery, it flows from negative to positive. Okay, that is the internal, inside. We are talking about the external, outside the circuit. Okay, so you go from positive to negative. Okay, now, when there's positive charge flow, there's also negative charge flow at the same time. Negative charge, we are referring to electrons. Okay, electrons can flow in the wires because metal, remember metal has many free electrons. The moment you connect to a battery, all these free electrons, they move in one direction because there's this electric field. Okay, now where is the electron flowing? We know that positive charge or current is flowing clockwise, but where is the electron flowing? The electron is flowing opposite to the current flow. Okay, now let me show the electron flow here. If I change this to electron here, you see the direction. Where is it going? It's going anti-clockwise, correct? Okay, so electron flow is from the negative to the positive. Something to take note, okay? Very important. The electron flow negative to positive, but current is positive to negative. They are always opposite. Always opposite. So if you have electron flowing to the right, let's say there's this electron moving to the right, where is the current moving? Opposite, right? So if it's moving to the right, then you know the current is moving to the left. Okay, so if the electron is moving down, then your current is moving up, always opposite. Right. Okay, now let me change back to current flow. Okay, like this. Now, next one, what if I want to measure what is the current in the circuit? I want to know how much is the current in the circuit. Now, look at your textbook page. Just flip it back to page, the chapter 2. Remember chapter 2 in Pre-01, physical quantity, page 18. Look at the table. Textbook page 18. Look at the table, physical quantity. We have the 5 physical quantities. Still remember? Mass, time, length, electric current, and temperature. So electric current is one of it. The base, the physical quantity, okay? Something that we can measure. So the unit and the symbol ampere, right, shows ampere. So current is measured in ampere, right? Current is measured in ampere. So we use ammeter to measure current. So I'm going to pull out this ammeter here. I want to measure what is the current in this circuit. So how do I connect this? Okay, you can see the load here. All they are connected one after another. Same for ammeter. The way I connect ammeter is also one after another. Okay, so series. In other words, I connect them in series. Okay, so let's say I'm going to add this over here. Okay, this one here. And then this one connected here. Okay, now What value it shows here? 0.45 ampere. Okay, 0.45, the symbol is ampere. That is the measure of current. So to measure current, you use an ammeter that must be connected in series, one after another, like this. Now, what if I want to measure the voltage of the circuit? Voltage is something that drives the current. Without voltage, there's no current. Okay, so current is the flow of charges, right? We discussed in last week is the flow of charges. Whenever you have a charge flow from one point to another point, it creates electricity, it creates current. So if you want to create continuous current flow, then you need continuous flow of charge. That's why you need a circuit. Okay, continuous flow of charge. Now, but the battery, the function of the battery is to provide voltage. Voltage is like something that pushes the charge flowing. Okay, something that pushes the charge flow. So the voltage, if I want to measure it, I would use a volt. This voltmeter is quite big. Okay, so I would use the voltmeter to measure. Now, the way I measure voltage is I need to pick 2 points before and after a specific component. Let's say I want to measure the voltage of the battery. Okay, then I would choose the point before and the point after. Across, we always measure voltage across a component. Okay, so I pin it over here and over here before after, then you can see the voltage of the battery. How many volts? This is 9 volts. Okay, 9 volts battery. So 9-volt battery gives me a current of 0.45. What if I want to measure the voltage of the light bulb? Here, I put it over here. Then I change. Again, I measure the voltage of the light bulb. That means I must connect it across the light bulb. One is before, one is after, like this. How many volts? 4.5 volt. Okay, so here again, I want to measure the resistor before and after here. Over here. Oops, negative. You see negative is because the terminal is the opposite terminal. Okay, so 4.5 volt again. 4.5 volt across the resistor. Why do we need a resistor in a circuit? If you don't have resistor, right, then the current will be too large. Okay, the resistance is to bring down the current so that it is not too large. If you have too large current in a circuit, it will cause fire easily. It will cause overheating. Okay, so that's why in any circuit we need resistor. We need a resistor, and resistor can be anything. It can be a load. Even the light bulb also has resistance. Okay, also has resistance. It can be a load or anything. Okay, here. Now, what if I increase the voltage of the battery? What do you think will happen to the current if I increase the voltage? Let's say I increase the voltage to, this is 9 volt, right? I increase to, let's say 18 volt. Observe the current values. Here, initially is 0.45. So if I increase to 18, okay, 18. Now, see the current double, right? 0.9 ampere. And you can see the flow of the charge is now faster. It flows faster right now. The faster the charge flows, the higher the current. Okay, so that means I can say that the higher the voltage, if I keep on increasing the voltage, what happened to the current? The current also increased because voltage is, think of it like something that pushes the current, pushes the charge. If I push it with greater force, then it flows faster. So if the voltage is high, then the current is high. Okay. Okay, now. Okay, in an electric circuit, some components are all of the component, okay, all of the component, they must be a conductor. They are a conductor. What is a conductor again? Look at your textbook, back to 207. The table on top, okay, point number 6. 3 categories: conductors, insulators, and resistors. Conductors, what is it? Okay, they are materials that allow electricity to pass through them easily. An insulator is the opposite. Do not allow electricity to pass through them. So example of a conductor is like metal, okay, metals, copper, silver, gold, right? So copper is used as wire, the wiring, electrical wiring, okay, because they are easily bent, okay, very easy, you can bend it. So that's why they use copper to make wiring. And insulators like plastic, rubber, glass, fibers, okay, that do not allow electricity to pass through them easily. Now, if I connect an insulator in the electric circuit, what will happen? Is there any current flow if I connect insulator in the circuit? Okay, let's see what insulator we have here. Okay, dollar bill, paper clip, coin, eraser. Okay, let's try this for. Now, I'm going to detach over here. Let's see. Okay, here. Adjust this a bit. Okay, let's try a coin. Will there be current flow if I connect this in the circuit? Let's see. Yes. Okay. Why? Because coin usually made of silver, gold, right? So it's metal. It's metal. It's metal, so electricity can flow. The charge can flow. The charge can flow, then there's electricity. Now, how about a look at the current and the value of the current, 0.9 ampere. If I connect to a coin, current is 0.9 ampere. If I connect to, let's say I connect to a, oops, paper clip. Again, there's current. That's current flow. Okay, there's current flow. If I connect to eraser, say, can the charge flow through it? Is there any current flow? No. Okay, no current flow, meaning that the circuit is complete or incomplete? The circuit is complete, right? It's complete, but because that one is the insulator, so current cannot flow. Okay, so the difference between conductor, insulator, and then you have the third row, it says resistors, right? So look at what is resistors? They are materials that limit or regulate the amount of electricity passing through them. Again, the second column, okay, the explanation, they are materials that limit or regulate. Regulate means control the amount of current that is allowed to pass through. Okay, so that's the resistors. So they convert electrical energy into other forms of energy. Because of resistance, when current flow past it, it converts some of the current into heat energy, some of the electrical energy into heat energy. That is why the bulb lights up, that is why the bulb heats up after a certain period of time, because it contains resistance. And same with the resistor over here. If you turn on the circuit for a short period of time, you'll find that after that, the temperature rises of the resistor. It's because resistance convert electrical energy into heat energy. Okay, so there's this downside and also the advantage to it. The advantage of resistor is I can control the current in the circuit, because without resistors, it will be too large. The current will be too large and overheating will happen easily. We don't want that to happen. You may have heard of short circuit. Later we'll talk about short circuit. What is a short circuit? Short circuit is like too large current flowing in the circuit that causes overheating and fire. Okay, so short circuit normally happen is because you don't have a resistor in the circuit. Okay, so we must have resistor in the circuit. So that is the advantage to control the current, and the disadvantage is that it can cause heating. Okay, it can cause heating, meaning that some of the electrical energy will go to the heat instead of going to light energy in this case. Okay. Now, done with this one, a few components, the components, electrical components, and open closed circuit, and also conductor and insulator, right? So now we go into the types of circuit. Same page, the table down there. There are two types of circuits in general: series and parallel. Now, here we are going to study the nature or the difference between these two types. I'm going to construct a series circuit. Okay, actually, this is a series circuit. Now, let me construct a new one. Very simple. I just use, okay, close this. I switch it to current flowing. Okay, I'm going to put 3 light bulbs in series with one another, like this. Yeah, by the way, is it very laggy at your on your side? If very laggy on your side, let me know. Okay, I connect like this. And this one over here. Okay. Now let me put the ammeter in. Let's see, just want to see how the current changes. Okay. Show the values. Now here we have a series circuit. A series circuit, how do you identify a series circuit? Very easy. You see how many paths it has. Just one path. How many paths can the current take? Just one. Come out from the negative, move in the wire, and come back to the negative. There's no other choices. There's just one path. So that is a series. In other words, you can also think about it as the load are arranged one after another in a single wire. Okay, that is series. One single loop. That's just one loop. Okay, so look at series circuit on the left column. Okay, on left column. It says that the loads are arranged one after one in a single loop. Okay, so a single loop or single branch is a series. Now, there's only one path for electricity to flow through. The advantage. What are the advantage of a series circuit? Why do I want to arrange it like this? First, it's very simple. Sorry. Excuse me. First advantage is that it is very simple. Simple to arrange. Okay, it's not very difficult to construct in real life. Okay, and then the disadvantage is when you have more load in the circuit, it will greatly reduce the current in the circuit. Okay, you see here, what is the current showing? 0.30 ampere. Let's say if I remove one bulb, I only connect 2 bulbs. Oops. Okay, I only connect 2 bulbs like this. What is the value of the current? 0.45 greater, right? So less load, okay, less load, more current. More load, less current. So the more bulb you add, the smaller the current in the circuit. The dimmer will be the light bulb. Again, in a series circuit, the disadvantage is that the more load you add, the smaller the current and the dimmer the light bulb. Okay, so here I only have two load is 0.45 ampere. So if I add back the bulb, so over here, oops. Okay. If I add back like this, then again, you can see the current come down. Just now was 0.45, right? So it now decreases down to 0.30 ampere. The brightness decreases, okay, become dimmer and dimmer. And that is the first disadvantage, okay? So you see here, the dash, please highlight the dash line. You see the advantage of a series circuit is simple to build, okay? That's the first one. And the disadvantage, the first point, it says when more loads are added, the total resistance in the circuit increases. Okay, that means when you add more load, the resistance total will increase and the current comes down. The light bulb become dimmer. Okay, so all the resistance, they stack up. Why? Because you add more load, right? You get more resistance. So the current becomes smaller and smaller. Now, the second disadvantage, it says that when one load is damaged, it affects the functionality of the other loads. Meaning that if one bulb is damaged, there's a break in the circuit. Okay, it will, if one bulb is damaged, then it will cut the entire circuit. It will cut the whole circuit. No current will flow in the circuit. Okay, let's say if I cut this point, you can see that no more current flowing in any point in the circuit. Every point, okay, there's no current flow. So that is the disadvantage, meaning that if one load is damaged, the whole circuit is affected. Everybody is affected. If you have 10 bulbs, one bulb is damaged, the 9 bulbs all they do not light up. They are all affected. Okay, because you only have one path. You only have one path for the electricity to flow. So if there's a cut in that path, then electricity cannot flow anymore. If you give it 2 or 3 paths, that's a different story, right? So this is only one path. So when there's damage, then no more current. Okay, so that is the disadvantage of a series circuit. Please remember the advantage and disadvantage. Okay, now we go to parallel. Okay, we go to parallel circuit. How do you connect a parallel circuit? Okay, we start with our power supply. Okay, I'm going to put, oops, this one over here. I put the load here and here. And here, let's put 3. Okay, this. You can see there are points where the wire branch out into 2 wire, right? Like this point here, 1 branch out into 2. Maybe I put 1 ammeter just to see the current flow. Okay, I put it over here. Okay, like this. Let's check the. Okay. This is a parallel circuit. How do you tell? Look at the loop. How many loop that current can flow? Okay, let me just get rid of this one so that you can see easily. Okay, let's see, look at the schematic diagram here first, the symbol. Current start from where? Negative or positive? Negative over here, positive over here. Current start from positive terminal, flows here. Look at the arrow. Down here. When it reaches this point, where will it go? Is it here or here? The current is given two choices. Go left or go down. Okay, if you are a driver, you reach a junction, left or right. Some will go left, some will go right, correct? So answer is both. Answer is both. The current will go in both directions. Some current go here, some current go down, okay? And then the current that comes in here flow past the light bulb, come up from here, then it flow back to the negative terminal. That makes one complete loop. This is one loop. The current that flows down reaches the second junction over here. Again, some current will go in, some current will go down. Some driver will go this road, some driver will go this road. Okay, so both. Now the current go in here, again, come back and back to the negative. That's the second loop. And the last one, the current go here, only one path, right? So it has to turn over here and come back. So you have the third loop. You have three loops in the parallels, in this parallel circuit. How about your series? Your series, if you look back at your series, here plus go out, there's no path to choose, right? Just one path, so just one loop. Okay. All right. So, okay, where are we? Just now I was looking at the this thing keep showing up. I think it's because my computer is not plugged in, so it's kind of laggy here. Okay, never mind. Okay, come back here. So this one, three loops, three branches. That is, if you have more than one branch, then that is a parallel circuit. Okay, so this is a parallel circuit. You can look at the diagram, the symbol diagram on the right, the second column. The loads are arranged in multiple branches. Okay, the first bullet point. There are more than one path for electricity to flow through. Okay, what is the advantage? Again, we look at the advantage and the disadvantage of a parallel. Advantage is that when you add more load in a parallel circuit, the resistance will drop because you are providing more path for the current to choose. So the more branches you add, the more choices for the current to choose, okay, the easier the flow of the current. Think of it like that. The more efficient the current can flow because it has more path, right? So that means the total resistance of the circuit will come down. What is resistance again? Something that slows down the current, okay? Think of it like something that resists the current flow. So when you add more loads in the parallel circuit, the total resistance come down. And what happened to the current? The current will rise. The current will increase. You can see, you can compare by looking at these two circuits. Which one has a greater current? The parallel, right? 2.7 ampere. The series is 0.30 ampere. Okay. Same voltage of the battery. Let me show the values here now. All 9 volts. Okay, 9 volt, same voltage. Current should be the same, right? But this one is greater, this one is smaller because of the resistance. Because of the resistance. You see this one, what is this? A 10, and then this symbol here. This symbol is called as is called ohm. OHM, ohm. Omega. Okay, they are omega, short as ohm. It is the unit of resistance. Okay, 1 ohm, 2 ohm, 10 ohm. So this one, the resistance are all the same. The resistance of the bulb is 10 ohm, 10 ohm, 10 ohm. Okay, so which one, again, which resistance is higher? We are talking about the overall resistance of the circuit. For the series, resistance, overall resistance, okay, I'll call it total resistance. Higher, total resistance higher. So what happens if resistance is high? Current is low. Current is lower. For the parallel circuit, total resistance is lower. So current is higher. Okay, so the series one is like the charge has to go through one after another. Go through this one and go through this one, go through this one. But for the parallel circuit, the charge can choose. Okay, for example, you can think of it like this. Let's say why this one, the resistance is higher, and why this one is lower. Okay, let's say I got 3 charge. Positive, 3 positive charge. 3 positive charge, like 3 drivers, they go in one single lane. Okay, 3 drivers, they go in one single lane. And they have to go through this toll booth. Okay, they have to pay the ticket then to pass the toll. This toll booth, there are 3 toll booths. The first driver come here, the second driver has to wait in line, right? So it has to wait the first one to go through the first toll booth, and then only his turn. Okay, so that means it has to wait the first driver, the first charge, to go through the first bulb, the second bulb, the third bulb, and then only the second charge go cross it. Okay, only the second charge cross the booth like this. So meaning that all these 3 charges, they flow past the resistance one after another. There's no choice for them to choose. They have to go through it all. And when the first one flow, the second one has to wait. The third one has to wait. They all wait in line. So that means, is it efficient? Is the traffic efficient? If the 3 drivers like this, not efficient, right? Because you only have one, think of it like you only have one single lane, 3 toll booths in series, one after another. Okay, compare that to 3 lanes and 1 toll booth in each lane. Okay, you see, here I got 1 lane, 3 stops, and you compare to 3 lanes and 1 stop in each lane. Which one is more efficient? The second one, because if you have 3 drivers coming, they can choose, right? The first driver can go to the first lane, the second one can go to the second one, the third one can the third one. But for the single lane, 3 drivers come in, the second driver and the third driver has to wait at the back for the first one to cross all the booth. Then only they can cross. So the second one, this one is the parallel circuit. Is the parallel circuit. That means you have 3 charge here. 1 charge can go to the first branch. The second charge can go to the second branch. The third one can go here. So they cross this one. The movement, we are talking about the flow of the charges, is more efficient. Is more efficient. So more efficient means less resistance, less traffic jam. Okay, so the first one, the series, the flow, is it efficient? Not efficient. So not efficient means there's traffic jam, there's resistance. Okay, there's resistance. So the series has high resistance. That is the reason why. And the parallel has lower resistance. Does that make sense? Okay. Okay, we'll stop for a while and I want you to do, excuse me, revision 1. Your homework, I asked you to do revision 1, question 1 to 3, right? So now you do 4, 5. 4, 5, and 6. Okay, I'll give you a minute and we look at the answers after that. After you finish 4, 5, 6, then I want to continue a little bit more. Okay, I want to continue a little bit more. Okay, I'll give you about 5 minutes. So 11:15, we will continue. Let me go and get my charger first. I'll be back in a minute. Okay, finished. Okay, Jollity, question 5. It is a, what circuit is this? Just type your answer in the chat. We start with question 5, the first column. Jollity, where's Jollity? Okay, Jollity, yes. Number 5. It is a, what circuit is this? What type of circuit is this? Series or parallel? It is a parallel or series circuit. This one. Parallel. Okay, it is a parallel circuit. The loads are arranged in a, is it one loop or more than one loop? More than one or one loop? More, right? So the loads, all the loads means the resistors or the light bulbs are arranged in multiple, okay, multiple loops. There are more than one path for electricity to flow. And when one of the components is faulty, the other components in other loops are not. What's the answer? Affected. Okay, yes, correct. Are not affected. That means if one damage, the rest still. Oh, I forgot to show you this. Right, when one damage. Okay, later we go back to the circuit. Okay, now on the right, this one you just take the opposite. It is a series circuit, and the loads are arranged one after one in a single loop. Okay, there are only one path for electricity to flow through. When one of the components is faulty, the other component in other loops are affected, not affected. Sorry, affected. This is not affected. This is affected. Okay, so this one is a open circuit. Open circuit, is there current flow? No current flow. Huh? Closed circuit, current flows in the circuit. Okay, next page. Insulators do not allow electricity to pass through at all. And wood ceramic. Resistors opposes movement of electricity. Opposes means go against the movement of electricity. So for example, nichrome and tungsten, okay, they are the common materials that usually they are very high resistance. Okay, conductors allow electricity to flow easily. Copper, silver, metal in general. Okay, we haven't discussed the answer, this one. Okay, so number one, electricity is the flow of charge, flow of charges. It is a what energy source, because it can only be obtained when it's a secondary energy source because it can only be obtained when the primary energy sources such as fossil fuel and solar energy convert to it. So it is a secondary. You always convert from something. Now, symbol, components, battery. This one is single battery. So number 4. Switch. Okay, number 2 is this one. Open switch. This one. A resistor got 2 symbols, guys. One is this one rectangular box. It's hollow inside. This one is different. The resistor and the fuse is different. The fuse, if you look at fuse, this is fuse. Inside got a line. But for resistor, inside there's no line. Okay. Or you can also draw it like this. Like this jagged line. Okay, this is also a symbol of resistors. Okay, you draw it inside. This one, draw it beside this. Then we have voltmeter. It's V. And bulb. And we have fuse. What is I? This is variable resistors. Okay, it actually has a slider. This is like a coil of wire. It's actually a coil of wire, and it has a slider that you can adjust how much length you want to include. Okay, how much length of the wire you want to include. If you use more length, that means higher resistance, because even wire carry resistance. Short wire and long wire. If the charge move across a very long wire, that's higher resistance than a short wire. Excuse me. So we are adjusting the length of the wire here to adjust the resistance. Okay, you can think of it like there's this coil of wire and then a slider on top. Let you adjust how much length of wire you want to include. You want to take, okay? So it's variable resistors. That means we can control the resistance by controlling the length of the wire. This is this one. Okay, number 6. A variable resistor has an arrow, okay, crossing it like this. And the last one we have, what's this? Closed switch. Okay. Let me go back to the this one finished. Anybody still copying? Okay, 3A, electric generator kinetic energy to electrical. Chemical. Okay, finish. Okay, we go back to the website. Just want to show you this. Okay, we talked about the advantage and disadvantages, right? Okay, let's revise a bit. For series, advantage is simple to build, very easy to connect. Disadvantage is when one damage affects the whole thing. For parallel, advantage is very low resistance. Okay, lower resistance than the series, so you have higher current. And the disadvantage is when there's another advantage. Okay, the first advantage is low resistance. The second advantage is when one device is broken, when one is damaged. So if I disconnect this, say I cut this, other two bulbs still lights up. Okay, so that means electric current still flows in the second and the third branch. Okay, only this path is broken, so still it can flow in other paths. So that is the second advantage. How about the disadvantage of parallel? Disadvantage of parallel is very difficult to connect. Okay, very difficult to connect compared to series. Okay, compared to series is more difficult. But overall, which one is better? The parallel circuit. Okay, the parallel circuit. Your house lighting circuit, okay, the lighting are in parallel circuit. Okay, so you don't have like a single switch that switch on all the lights, right? You switch on the light in the room, in the living room, in other room. So it's like you're controlling the switch, okay, in this branch, and this branch. So it's connected in parallel circuit, not series. Unless like you have a switch when you turn on and the whole lights up. Okay, so the lighting circuit in your house is parallel circuit. And also because of the low resistance. Okay, we don't want high resistance. Okay, now for the next part, what time is it? We have 11:30. Okay, we have 15 more minutes. I want to continue 10 more minutes. And yeah, I'll let you go at 11:40. Let me just finish up the current part. The next part, if you look at your textbook, page 194, we will look at more in depth what is current, what is voltage, and what is resistance. Okay, here, let me go to give me a second. Okay, I'm trying to find the bookmark. Electric circuit. Okay, give me a second here. I'm trying to find the website. Thought I already bookmarked the website. Yeah, this one. What is this? Okay, yeah, this one. Okay, it's here the whole time. All right. Okay. Okay, this one. Okay. Now look at this one. The idea behind current. So far we know that current is the flow of charge. Okay, you have electron flowing. If electron flow in this direction, where is current? Opposite direction. Okay. So here I have a simple circuit that I connect to a power supply and a load and also a conductor. Now we have two, insulator and conductor. Let me switch this to conductor. So when I switch to conductor, you can see that it is connected to the circuit and the bulb lights up. Okay, this orange color here, shaded. So the bulb lights up. And okay, I want you to observe the electron flowing. Now, let me take away the battery first, like this. Okay, no battery. Okay, no battery. You see the blue dot? The blue dot that is like moving around the positive charge. The positive charge is the atom, the nucleus of the atom. And the blue dot is the electron. Okay, the electron orbiting around the atom. And these are actually the free electrons. The free electrons. Free electrons means they are not bounded by the atom. They are free to move. When you apply a push, then they will move. That push comes from the battery. So initially, if you look at where they are moving, they just move in random direction, right? Every single electron, they move in random directions. They are doing their own thing. They are minding their own business, all right? So there's no flow. There's no collective flow of electron in one specific direction. Now, the moment I apply battery, if I put a battery here, then observe the flow of the electron. Let me zoom in a bit. Okay, it starts to flow in same direction, even though it's not in straight line, but you can still see that they flow in one direction. This one is like they flow up, and this one they flow down from here. Okay, so because there is a voltage applied, so it pushes the electron to flow in one specific direction. If I put more battery, add one more battery, and the flow, what happened? What changes can you see? The speed, right? The speed of the electron flow increases. Now if I add one more, 3 batteries, and look at the speed. The speed of the charge, the speed of the electron, faster and faster and faster. So that means higher current. When you increase battery, you get higher current, right? So current correspond to the speed at which the charge is flowing. How fast the charge flow. The faster they flow, the higher the current, right? So again, current is the flow of charge, and the faster the flow of the charge, the higher the current. Okay, do you catch it? Is it lagging? I see the pop-up say lagging. Okay, did you get it? Did you get it? I repeat again. I repeat again. So current is the flow of charge, and the faster the flow, the higher the current. You can think of it like how fast the electron flow past one point. Okay, like if I draw a line here, if I just draw a line across like this, how many electrons flowing past the line in 1 second? Okay, how fast? How many electrons crossing this line in 1 second? The more electron crosses the line in 1 second, that means the flow is fast. Okay, the higher the speed of the flow and the higher the current. Right, now if I switch to insulator, what happened? If I switch to insulator, does the bulb light up? No. Look at what happened to the electron. You see this blue shaded region around the positive charge? That means the electron is held by the nucleus. Okay, it is held by the nucleus. It cannot come out. They are, in other words, they are not the free electrons. They are not free electrons. So for insulator, they do not have free electrons. And even though you put battery, the electron cannot move. It cannot leave the nucleus. So you just continue to do the orbit here, right? But conductor is different. Conductor, many free electrons. So you get the flow of the electrons when the voltage is applied. Okay, so yep. So that's a wrap for today. The rest, which is on Monday, I will continue on the voltage. We'll look more into what is causing the flow of charge. We know that so far, current is the flow of charge, but you need something to cause the flow of charge. Okay, you need something to make the charge to flow. What is that? That we call it as electric potential. Okay, so that one we will continue in the next lesson.